there, Math Hoppers! In this video lesson, we are going to go over vertical asymptotes for rational functions. And believe it or not, we have seen vertical asymptotes in algebra before. We've seen them in algebra 2, and maybe even in algebra 1. But for sure, we never talked about them. Asymptote is a new word to our vocabulary. Maybe we were just ignoring them, hoping they'd simply go away. But that very rarely works with anything in life. So let's see where we've seen these. Recall the parent function for a rational function. Remember, rational functions were just functions in the form of a fraction that had an expression in the numerator as well as an expression in the denominator. And the most basic form of that was the parent function 1 over x. And we would graph it, usually from making a table of values. And even though we never talked about it, we didn't draw it in, there was a vertical asymptote. It was a line that the graph never passed at x equals 0. And that kind of made perfect sense to us. We knew you couldn't divide by 0. We had learned NO, it is not okay to divide by 0. So we understood that this graph would never pass that vertical line. So if you are a Monty Python fan, just think of it as the none shall pass line, right? Because the graph will never pass that vertical line. All right, so we have said for a long time you can't divide by 0. A, it's impossible, and B, bad things happen. Those bad things are vertical asymptotes. So vertical asymptotes are places of infinite discontinuity in a rational function. All right, discontinuity. Super complicated word. It simply means the graph isn't continuous. What does that mean? Just means you can't graph it without picking up your pencil. So rational functions, remember this is the formal mathematical symbolism, means this is a function, it passes the vertical line test, whose variable is x, in the form ax over bx, where that means there's some expression in the numerator and another one in the denominator. And vertical asymptotes happen in these graphs where the graph goes off without bound to either positive or negative infinity. So let's look at two here. Okay, we see two functions. They both have two sets of infinite discontinuity, right? This graph here has one at -4, this one and at 1. And what's happening is, to the left of this vertical asymptote, the graph is going off without bound to negative infinity. On the right side, the graph is going off without bound to positive infinity. And then same thing's happening over here. The graph is continuing without bound to negative infinity and over here to positive infinity. And you see the same behavior, even though this is a different function, takes on a different shape. Okay, you see this one will get closer and closer and closer to the vertical asymptote further down, where we really can't see it in this screenshot, but it will happen. It will look just like these. It will come right up against that line, but never cross it. Okay, so how do we find these things? Well, you may have already figured out, if we can't divide by 0, vertical asymptotes are the values that make the denominator of a rational function 0. However, one little caveat that we won't do too much with in this course, that value can't also make the numerator 0. So you want the values of x that make the denominator 0 without also making the numerator 0. And let me just explain it, and we'll probably never talk about it again. If you have a number over 0, you have a vertical asymptote. But 0 over 0 is something different. It's not a vertical asymptote. It's actually a hole in the graph. It's a little blip where for the rest of the function, the graph follows a specific pattern, except not at that specific point. And we take that up in calculus. We really don't get into it here, but it's important to know. So how do we find vertical asymptotes? Well, the first thing we want to do, if it's the value of x that makes the denominator 0, set that denominator equal to 0 and solve for x. Then take that result from step 1, pop it into the numerator, just make sure we don't have 0 over 0. Because remember, 0 over 0 is not a vertical asymptote. And actually, you'll find in this course, you don't get very many examples where that happens because they know you don't know about it yet, but just get in the habit of doing it. All right, let's test a few. If we have the function f of x equals 5 divided by x squared minus 9, we want to find any vertical asymptotes there may be. Okay, first step, set the denominator equal to 0. And look at the denominator. It has that pattern x squared minus 9 that you learned in algebra 1. You may be already thinking, I know the answers are positive and -3, because you should remember this pattern of x plus 3, x minus 3. That was one of our special factors that we said would never go away. It never will go away. But if you don't remember that, no worries. Let's just solve for x. So get rid of negative 9 by adding 9 to both sides. You get x squared equals 9. Remember, the opposite of squaring is to take the square root of both sides. Also remember, all positive numbers have two square roots. They have a positive and a negative. Of course, not 0, but 0 is not positive. So we get two vertical asymptotes for this function at x equals 3 and x equals negative 3. There is no need to test it in the numerator because the numerator is just 5. There's no variable there. Also, if we're looking for patterns, because we had a quadratic in our denominator, it should make sense that there was a chance that we would have two vertical asymptotes because many, many quadratics have two solutions. All right, let's look at one more. f of x equals 2x minus 3 divided by x plus 4. Set the denominator equal to 0. That's a nice, easy denominator. X plus 4 equals 0. Subtract 4 from both sides. That's how we solve for x in this one. And we get x equals negative 4. Now our numerator is 2x minus 3, so we do have to pop negative 4 up into the numerator. Make sure we don't get a 0. 2 times negative 4 is negative 8. Minus 3 is negative 11. Negative 11 is not equal to 0, so we're good. We have a vertical asymptote at x equals negative 4. Many people write in and say, can't you find asymptotes from my TI-84? And the answer is sort of. Let me explain what I mean. If you go to second format in your TI-84, you will see detect asymptotes on down here. Or it might be off and then you'd have to turn it on. So yes, it detects asymptotes, but let me show you what it does. For this function, you would see this. Okay, so normally there'd be a traced line here. It makes it look like a hot mess. What detect asymptotes does is it removes that traced line. So you can come over here and say, okay, negative 1, negative 2, negative 3, negative 4 is what I got. And yeah, that appears to be my vertical asymptote. It does make it easy to verify your asymptote. It just doesn't calculate it for you. Like people expect it to say x equals this. And that's not really what it does. So you can use it, but it's more of a verification. All right? Remember, if you are going through these modules for your class or you're studying on your own and you come to something that you just can't do, you get a problem in class or a problem for homework or you're studying for a test, you should be subscribed to our YouTube channel. It exists for you. Submit those problems you can't figure out and we will make a custom solution for you. And then you will know how to do it. All right, Math Hoppers, until next time, take it easy.